Now exercise 4.10. A body of mass 0.4 kilogram moving with a constant speed of 10 meter per second to the north is subjected to a constant force of 8 Newton directed towards the south for 30 seconds. Take the instant the force is applied to be t equal to 0, the position of the body at that time to be x equal to 0, and predict its position at t equal to minus 5 second, 25 second and 100 second. Now see here, first of all understand the situation. See, the body which one is with mass 0.4 kilogram is moving in north direction with constant speed 10 meter per second. Then suppose when body reaches at this particular position, the external constant force of 8 Newton is applied in south direction. So as soon as we apply the force, that we have to take instant t equal to 0, and that position from where the force is applied, that we have to take x equal to 0. Clear? Now we have to find the positions of the object at t equal to minus 5 second, 25 second and 100 second. Here the force is applied only up to 30 seconds. Clear? Now see here, first of all, the position at time t equal to minus 5 second means what? Right? We know time never be negative, but here minus 5 second means when the force is applied, that is t equal to 0 second. Minus 5 second means before the force is applied at t equal to 5 second, what was the position? Right? That we have to find. So it is considered as minus 5. T equal to 0 and before that up to 5 second. Right? That we have to carry out the calculation. Right? Therefore it is taken as negative. Now see here. Mass that is given to you 0.4 kilogram, initial velocity that is 10 meter per second. That is towards north. Force is applied 8 Newton towards south, and that is for 30 seconds. Now here at t equal to 0, the force is applied. When we calculate the position at minus 5 second, at that time there is no force. So at that time the body that is moving with constant speed. So the distance d, that is equal to velocity into time. So xa position, that is equal to v0t, that is 10 into minus 5, that is minus 50 meter. It implies that the position of the body that is at 50 meter on left hand side of this t equal to 0 and x equal to 0 situation. Clear? Okay. Now we have to find the position at t equal to 25 seconds. So at t equal to 0, the force is applied. So when the force is applied, now the motion of the body, that will be accelerated one. So to find out its position at t equal to 25 seconds, we can use the equation of motion with constant acceleration. Now see here, position at t equal to 25 seconds. Acceleration, that is force upon mass, constant force applied, that is 8 Newton upon mass 0.4. Now here negative sign is introduced. Why? Because the body is moving in north direction and the force is applied in opposite direction. Clear? So minus 8 upon 0.4, that is equal to minus 20 meter per second square. Now position at t equal to 25 seconds. So we can use the equation x equal to v0t plus half at square. So this second position, B equation. So xb equal to V0t plus half AT square. Substitute the values. V0 10, T 25, half A, that is minus 20, so negative sign is taken here. 20 times, that is 25 square. So you will get 250 minus 6250, and that is equal to minus 6000 meter. Okay. Now third situation. Position at t equal to 100 second. Now here be careful. We have to divide this time into two parts, 30 second and 70 second. Why? Because the force is applied only up to 30 second. Clear? So up to 30 second, it will be accelerated. So first we have to find the position in first 30 second. Then after force is removed. Then after force is not applied. It implies that at 30 second, whatever the velocity is attained by the object, with that constant velocity, it will continue the motion for next 70 seconds, right? So that will be calculated separately. So in this manner, first we have to calculate force is acting for 30 seconds. So for that particular situation, we have to find the position. Therefore, up to 30 second, object will move with constant acceleration, and after that, for 70 second, object will move with constant velocity, which I already explained. Clear? Now, position at t1 equal to 30 second. So, accelerated motion, so x1 equal to v0 t1 plus half a t1 square. So, v0 10, t1 30, half a, that is minus 20, t1 30 square. So, that is 300 minus 9000, that is x1 equal to minus 8700 meter. Now we have to find the velocity attained by the object after 30 seconds. So we can use the equation v equal to v0 plus at. So v equal to v0 plus 81, v equal to 10 minus 20 into 30. So that is minus 590 meter per second. This negative sign represents this thing, the velocity that is in south direction. Now with this constant velocity, it will continue motion in south. So distance, that is velocity into time. So position at t equal to 70 second, x2 equal to vt2, v that is minus 590, t2 that is 70, so that is 41,300 meter, right? So after 100 second, the resultant position, that will be x1 plus x2, so that is minus 8700 minus 41300, that is minus 50,000 meter, that is minus 50 kilometer. So body will be at 50 kilometer in south direction after 100 second or at 100 second. Clear to all of you?